Welcome back to a very exciting lesson on how to find surface area of a triangular prism. So today we're working with a three-dimensional shape, which is very difficult for visual learners because I'm trying to teach you about a three-dimensional shape on a flat whiteboard. So I'm going to do my very best as usual, and any feedback is more than welcome. This shape here is a triangular prism drawn by me to the best of my ability. Keep in mind I'm a math teacher, not an art teacher. This is what a three-dimensional triangular prism would theoretically look like, okay? And then this here is what we call a net. So a lot of times we use nets because it's almost like you take a vertical slice through this three-dimensional shape so that we can see it better visually on a flat board or a flat piece of paper. So this is a triangular prism, and this is the net, which means as if we kind of theoretically cut it open and laid it out flat here so that we could see all of the shapes and all of the measurements. So just as a reminder, surface area is, since it's a three-dimensional figure, we're trying to find the total area of the entire surface or all of the surfaces, which means we have to find the individual areas of each individual shape, and then we have to find the total or the sum and add them all together. So in this particular, in a triangular prism, you actually have two shapes. As you see here in the net, if you were to cut this triangular prism and lay it flat, there are three rectangles, okay? So these three rectangles are the three lateral faces of this three-dimensional triangular prism, okay? This second shape, as you can see here in red, would be a triangle. So in a triangular prism, you have two shapes. You have rectangles and you have triangles, okay? These three rectangles are the lateral faces of this three-dimensional figure, and then the triangles are the base or the bases of this triangular prism, okay? The reason I'm explaining all of this is because you can't operate a vehicle until you take driver's ed lessons, okay? You need to know which pedal's the gas and which pedal's the brake. So it's the same for math. I can't just dive into a problem and start finding surface area if we don't understand what surface area is, okay? So for today's lesson, I'm going to use a tent, especially since I live in Denver, Colorado, and I'm very eager to hopefully go camping this summer. I'm going to use the real life example of a tent. So let's imagine that you have a tent in front of you. Let's say you're looking at the front of the tent, and let's say it's the shape of a triangle, okay? That's gonna be one of these red bases or the triangular shape within the triangular prism. So if I'm looking at that tent, the front is a triangle, so that means I need to have one triangle in the front of the tent and then one triangle in the back of the tent to make sure that I can sleep inside without coyotes and bears coming in, okay? So the red and colors are really important on a lesson like this. If you don't need them, more power to you. But if you have any kind of colored crayons, pencils, markers, highlighters, whatever have you, I really recommend having 4 different colors for today's lesson because it makes it easier to visually see, and then it keeps us organized, okay? So once again, we have the red, which are the triangles, which is the bases of this triangular prism. So the front of the tent that you would unzip, and then the back of the tent keeping you safe inside. And then these 3 rectangles, or these 3 lateral faces, would represent the one side of the tent, the second side of the tent, and then theoretically, I wish I had a third hand, the bottom of the tent, which is the horizontal purple line that we have here. So theoretically, the purple rectangle is what you would sleep on the bottom. So 3 lateral faces, they are 3 rectangles, rectangle 1, side of tent, rectangle 2, other side of tent. Rectangle 3, pretend I have a third arm, bottom of the tent that you'll lay on, and then 2 bases indicated in red, a front triangle and a back triangle to keep you safe within the tent, okay? So that's just a real life example that I'm going to use today. So let's get started. I'm going to start with this green triangle here, so of course I'm going to use my green marker, okay? now we have drawn a net, we have theoretically cut this triangular prism open, and we're trying to find the individual areas of the individual shapes, so that in the end we could add them all up and find the total, which will give us the surface area of the triangular prism, okay? So, I'm gonna label this number 1, okay? So, rectangle number 1. So, we are being organized with colors and with our labeling. And we're going to stay organized because this problem encompasses a lot of work, and if you lose your work and get sloppy, it's going to be very difficult. So, area, first thing, green rectangle, area of a rectangle, if you do not know, is length times width. So step 1, you always write your formulas to stay consistent and organized. If I am looking at this green rectangle, we have 2 variables or 2 unknowns. That means we need to pull out 2 pieces of information. If you look at this green rectangle, all they told us was that side measure is 3 meters. How would we possibly figure out what that side measure would be? If you are thinking to look across to the other triangle, you are 100% correct because the side lengths of a triangle are equivalent. So for the green triangle, we are going to be using the 3 meters and then the 6 meters, okay? So we now know that 6 meters, you always bring down your A, the area, the unknown of what we're looking for. Length, I'm going to plug in the 6 meters. Be careful, this does not become one solid number. When numbers or letters or variables are touching in math, that means multiplication. So we are going to do the 6 meters times our 3 meters, okay? 6 times 3 gives us 18. It does not give us 18 monkeys. It does not give us 18 rainbows. It is 18 meters. We want to be accurate in math and we want to stay consistent, okay? So congratulations, we could put a check mark. We just found out the area of one of the lateral faces, the green rectangle, is 18 meters. I'm going to write this off to the side just because I need to erase, but you do not, okay? So now we are going to move on to rectangle number 2, which is also the second lateral face. So I'm going to change my marker to purple. We're going to move directly to the right. We're going to stay organized, and this is going to be rectangle number 2. And I'm also doing it in purple so you can see visually as to which rectangle it corresponds to, okay? So we're trying to figure out lateral face number 2, rectangle number 2 in purple. Step 1, always area of a rectangle, length times width. Bring down your variable and your equal sign. So here we go again. We have 2 variables, 2 unknowns. That means we need 2 pieces of information. If you look back to this purple rectangle, they gave us a 5 meters, but once again, there's not another number directly in that purple triangle. So we need to know the measure of the side length. So once again, you can look here or here. Rectangles have equivalent side measures. So for the purple rectangle, we are going to be 5. I'm getting too excited. Let me take a breath. Okay, for the purple rectangle, we are going to be doing 5 meters times the 6 meters, okay? So 5 times 6, remember once again, this does not become 56. This becomes 5 times 6, and 5 times 6 is 30. Once again, we're not talking about 30 balloons, we're talking about 30 meters. So congratulations, I'm very proud of you. You can put a check mark. You have now found your second rectangle or your second lateral face, and I just put that 30 meters off to the side because I'm going to erase, okay? And I highly suggest boxing in or making a cloud around your area of each shape because in the end, we do need to find those quickly to be able to find the sum. And I just find that if you have them boxed in, it is easier for your eye to see what you're combining. All right. Awesome job. We're on to our third and last lateral face, which is the third and last rectangle, which is in blue. So this is the third or the, rectangle number 3, which is also lateral face number 3, which is also the last rectangle and the last lateral face we need to find before we get to the bases. So once again, hopefully this is becoming consistent. Step 1, you write your area formula, length times width, bring down your unknown, bring down your equal sign. Once again, we need a length and a width. We have 2 unknowns, we need 2 numbers. So now we're looking at the blue rectangle, the last one, the last lateral face. And this blue rectangle, cha-ching, they already gave us both of the numbers. They told us that this side is 4 meters and this side is 6 meters. So now we don't even have to look for other numbers. We're just gonna substitute those in here. So for the length, we're gonna do 6 times 4. Once again, it does not become 64, it's 6 times 4. So the area of our third rectangle, or our third and last lateral face, is going to be 24 meters, okay? And once again, I'm going to write this off to the side, just so that I have it for later, so that I can erase. So congratulations, take a deep breath. You just found the 3 rectangles, or the 3 lateral faces, which means we're almost done, okay? I wrote my 24 meters off to the side. You can put a little check mark in your third rectangle. So we are now done with the rectangles, and we're going to move to the last shape, which is the triangle. Triangle requires a different area formula than rectangle, and there's actually 2 that you can use. I never like to tell students or individuals which one to use, because your brain is completely different from mine, is completely different from the next person. So I'm going to show you the 2 different formulas, and you can pick which one you want to use, okay? One formula when you're looking for the area of a triangle, okay, is, I'll keep this in black. The area formula, one of them, is 1/2 times your base times your height, okay? This will give you the area of any triangle. However, I don't like to use this formula because working with 7th grade students, as soon as they see a fraction, that's it. It's like a deer in the headlights. They forget all their self-esteem and their confidence and their knowledge, and they just kind of black out. So yes, you can use this formula, but I'm not going to use that one. I'm going to actually use this one. So that's the one formula you can use, or area equals base times height divided by 2. Both of these formulas are equivalent. Both of these formulas are 100% mathematically correct, and both of these formulas will give you the correct answer. It's just preference. So like I said, I like to stay away from the 1/2 just because I feel like it keeps things a little bit cleaner and it's easier for 7th grade students, but you can use whatever one you want, okay? So we already found our 3 rectangles. We need to find the triangle. Let's pause here for a second and think about a theoretical triangular prism or a tent. If my front triangle is a certain size and the manufacturer makes the back 3 times as large, is that tent going to line up properly? Absolutely not. So when you're thinking about a triangular prism, a little bit of a shortcut is you don't have to find the area for each individual triangle because they need to be exactly equivalent. Those measurements need to be spot on, picture perfect, the same, or the seams won't line up correctly. So the good news is we only have to find the measure of one triangle and duplicate it. So we're really almost done, and I'm so proud of you. So let's, I have the red triangles, the triangles indicated in red. So we're going to now find the area of the triangle, okay? Once again, you can use whatever formula you want. I'm going to use area equals base times height divided by 2, okay? Bring down your A, bring down your equal sign. Now, base and height, there's 2 letters there, which means 2 variables, 2 unknowns. So I need to pull out 2 pieces of information from that triangle. A lot of times what happens, and this is where majority of students make a mistake, so don't get trapped. If you look at this triangle, they gave you 3 measurements, which is 1 too many. They gave you 3 millimeters, 4 millimeters, and 5 millimeters. We only need 2, okay? The trick that I will tell you is one of those measurements belongs to the rectangle and not to the triangle that we need. And if you're thinking the 5 on the bottom here, the 5 meters aligned with the horizontal purple line, that's the number that we don't need because that belongs to the rectangle, okay? So we need to use here the 3 meters and the 4 meters, okay? So I'm going to plug in 3 times 4. Once again, this does not become 34. It becomes 3 times 4 because they're touching, which indicates multiplication. Okay? Area equals 4 times 3 is 12, and 12 divided by 2 is 6. So now we were able to figure out that the area of one triangle is 6 meters. How many triangles do we have? We have 2. So, if you don't believe me, you can redo this process again for the theoretical back triangle or the other base, because there's 2 red triangles, a front and a back to your tent. Or you can just believe me that they are equivalent, so we can either just represent 6 twice, or you can have 6 times 2, which is 12. So I'm going to just write down 2 different 6s, okay? And then I'm actually going to erase this, and all we need to do now is find the total, which is the sum, and then we're done, and you have mastered surface area of triangular prisms, okay? So whatever you're writing on, a whiteboard, a loose leaf paper, a notebook, whatever have you, this triangular prism has 5 lateral faces, 3 rectangles, and 2 triangles. So now we're going to add them together. So our green rectangle was 18 meters, okay? Our purple triangle was 30 meters, and sorry, I'm saying triangle, I mean rectangle. I just love this lesson, I'm so excited, I can't hide it. So, once again, to say this the correct way, the green rectangle we found was 18 meters for area. The purple rectangle, we found the area to be 30 meters, and then the blue rectangle we found to be 24 meters, okay? So that's 3 of our dimensions. We're missing 2 of them, and it's the front and the back bases, or the triangles. So then we have also, will you see this here? Sure. Plus 6 meters, and then plus another 6 meters. Okay, and if you want, I can go above these and label them for anybody that needs to. The 18 meters was the green rectangle. The 30 meters was the purple rectangle. Okay, the 24 meters represents the blue rectangle. And then the 6 and the 6 were the 2 triangles, or your 2 bases. So 2 different shapes, triangles and rectangles, and now we're going to add them all together, okay? You can simply do 18 meters plus 30 meters plus 24 meters plus 6 meters plus 6 meters in your calculator, and when you do that, you get 84. It would be a real shame to not finish this off with every little specific detail after doing all of this beautiful work, okay? So, the surface area of this triangular prism is 84 meters squared. Congratulations. Pat yourself on the back. You have just found the surface area of a triangular prism. I hope you have a wonderful day, and I hope this was helpful. Stay happy and healthy and positive always.